Hi friends, Mrs. McBride here. The last thing I wanted to talk to you about today is the theory of everything. Or if you got really excited, you could call this the TOE, the theory of everything. Or some people also like to call this the grand unified theory, or the gut. Now you don't have to take notes on this. This is just sort of an FYI, because I always feel like you guys are smart and some of you are going to go on to study physics, and I don't want you to think that what we're learning in class is the full picture. Okay, now I just gave you notes on the 5 fundamental forces, which is true in classical or Newtonian mechanics. Okay, if you would ask most physicists, they would say that there are really 4 fundamental forces. Okay, and they would say that these 4 fundamental forces relate to classical mechanics, but there's only one that's the same. And that guy is gravity. And gravity is actually the weakest, or sort of the one that's not as important compared to the other 4. Now, do you know the other 4? Well, one of them we've definitely talked about, and that is the electromagnetic force. Okay, there's also the strong, sometimes people call this the strong nuclear force, because this is what's responsible for keeping the nucleus together, right? So if you think about it inside the nucleus, right, you've got all of these protons and neutrons trying to coexist. Well, we know that if protons both have a positive charge, they don't really want to be next to each other, right? Opposites attract and likes are going to repel each other. So there must be a pretty strong force that's going to keep this nucleus together. And the last one is called the weak force. It's obviously not as strong as the strong force. This is responsible for radioactivity. So physicists again would say, these are what we would describe the 4 fundamental forces. And what everyone from Einstein and beyond has been trying to do is figure out, how do these 4 forces work together to form the theory of everything? Or is there one set of laws that governs all types of particles and all types of motion? At the current moment, we don't have a theory of everything, and we don't have a grand unified theory. Maybe someday one of you guys will figure it out. But all I wanted to do today is just talk to you a little bit about the other types of physics, because there's some other cool stuff going on that unfortunately we won't be able to touch on. So I'm going to break this into 4 boxes, and I'm going to say that the ones up top are the smaller in size, and the ones at the bottom are the bigger in size. And we're going to talk about speed here. These guys are the slows, these guys are the fast. Okay, so where do we live right now? We live down here in Newtonian mechanics. Okay, so as I said earlier, what we're studying are the big and the slow. Okay, all of the things that we're learning are going to be in this box. But what I wanted to talk to you about is like, hey, there's all this other cool stuff going on. One of my personal favorite things is over here. What happens when these big things start to move fast? Well, we move into something called relativistic mechanics, or the theory of relativity. Okay, which basically says that, remember, when things go really fast, like close to the speed of light, they start to do some weird things. And this is what comes into Einstein's theory of relativity. You've got special relativity and general relativity. Basically, he says that once you start moving really fast, these equations and this information, this basically branch of physics, doesn't work anymore when you start moving so quickly. Okay? Pretty cool. In college, you could take a whole class on just what happens in this particular box. Same thing over here. Well, what happens when you've got things that are moving slow, but also are really small? Well, we would call this quantum mechanics. Okay, so quantum mechanics, again, is things that are small and slow. Quantum mechanics has some crazy things that happen there, talking about what is the probability of different events happening? What is the probability of something very small moving slowly going through a wall? This is where you get the idea of multiple different dimensions in the world happening at the same time. You know, so do you ever think like, what decision am I going to make? Okay, well, the idea in quantum mechanics is that whatever decision you make, you're going to follow that decision into this particular universe, but there could be another universe or another dimension that's happening with the other side of your decision. Okay, it's all about probability here. And the one that I sort of know the least about is this box over here, which is talking about things that are small and fast. And this right here is called quantum field theory. All right. So again, the reason why we're talking about this is the stuff that we're learning is really important, you know, and it's really important to understand, really fully understand what's happening in this box down here of things that move big and slow. All I wanted to do is tell you that, hey, there's more out there in the world of physics other than just what we're learning. So I encourage you to spend the rest of the time looking up some stuff on YouTube. I'll give you a video that talks about the grand unified theory and see if you can learn something new about some of these other topics. Enjoy!